welcome to my channel. Today's video is Permutations and Combinations part 3. So make sure that you have watched part 1 and part 2. So if you like my video, subscribe my channel so that you will get the notifications of further classes. So today we are going to study combinations. So what is a combination? Combination is the number of selection of objects are taken some or all at a time when order does not matter. Okay, combination is the number of selection of objects taken some or all at a time when order does not matter. Here order is not important. Okay, so for example, select 3 books from the stack of 5 books. This is for combination. Okay, combinations of 3 books. Okay, so here in last class we learnt about permutations with examples, right? So what is a permutation? Permutations is the number of ways of arrangements of objects in a definite order taken some or all at a time, isn't it? That is permutation. Permutation is about arrangements. Okay, permutation is about arrangements and combination is about selection. And in permutations, order matters, right? In combinations, order does not matter. See, difference between permutations and combinations can be identified by their concepts. Let us see. Permutations and combinations. Okay. So here, permutation is about arrangements, right? It is about arrangements. And combinations is about selection. Okay. So here order matters. Here order does not matter. Okay, remember in combinations order does not matter. It is the number of selection of objects when order does not matter. Okay, and here let us take example. Okay, see, arrange 3 digits from the 1, 2, 3, 4, 5. Okay, from the numbers 1, 2, 3, 4, 5. Okay, so 3 digits. Arrange 3 digits from 1, 2, 3, 4, 5. See how we will arrange it. We know that 1, 2, 3. Sorry. 1, 2, 3. Okay, we can write 3, 2, 1 or 1, 3, 2. Isn't it? So here in this way we will arrange the 3-digit numbers from 1, 2, 3, 4, 5. Okay, that we have already learned. Now in combinations, see here select 3 digits from 1, 2, 3, 4, 5. Okay, select 3 digits from 1, 2, 3, 4, 5. See here we will write, if we write 1, 2, 3, okay, 3, 2, 1, 1, 3, 2, see these are same. Okay, because order does not matter. Okay, 1, 2, 3, 3, 2, 1, 1, 3, 2, these are same in combinations. So remember in combinations order does not matter. Okay, so here so what is a combination? Combination is the number of selection of objects when the order does not matter, right? So here let us see another example. Okay, so if we have 4 different objects, okay, if we have 4 different objects A, B, C and D, okay, if we have 4 different objects A, B, C and D, if we have to make combinations, those will be AB, okay, BC, then CB, then AC, AD, BC already written, BD, right? Over it. Okay. See here, these are the combinations. Okay, we have 4 different objects. We have 4 different objects A, B, C and D. Yes, taken 2 at a time. Okay, taken 2 at a time Then if we have to make combinations, this will be AB, BC, CD, AC, AD, BD. Here AB and BA are same in combinations. Why? Because order does not matter. Here order is not important. Okay. So AB and BA are same in combinations. Then what about permutations? In permutations, AB and BA are different, right? Because their order matters. Okay, it does matter order, right? So here, next. So what is a combination? So when the number of combinations n different objects taken r at a time is denoted by NCR. Okay, that is equal to n factorial divided by n minus r factorial into r factorial. Okay, it is the formula for combinations, NCR. Okay, the number of combinations of n different objects taken r at a time is NCR, that is equal to n factorial divided by n minus r factorial into r factorial. So what is permutation formula? NPR for n different objects, n factorial divided by n minus r factorial. Isn't it? So number of n different objects taken r at a time, number of combinations of n different objects taken r at a time is NCR, that is equal to n factorial divided by n minus r factorial into r factorial. In permutations, number of permutations of n different objects taken r at a time, NPR, that is equal to n factorial divided by n minus r factorial. Okay, so here now we will write the relationship between permutations and combinations. See, we have noticed in last example, we have written AB, okay, BC and CD, okay, etc. See here, that is the combinations, right? Here we can write each selection AB, we can write BA in permutations, right? So I will write the formula. The relationship between permutations and combinations, we can write NCR is equal to NPR into R factorial. Okay, NCR is equal to NPR into R factorial. See, from this we can say, right? In the formula we can say, but how? Here, see, in combinations, order does not matter, right? So we will write A, B, B, C, C, D. But for each selection, we can arrange R times. Okay, see, we can arrange R times. See here, taken two at a time. Okay, AB, we can write AB and BA in permutations. Okay, so for each selection, we can arrange R times. Okay, so here the formula is a relationship between combinations and permutations for n different objects. NCR is equal to NPR into R factorial. So from the formula itself we can say, see, if we multiply R factorial here, we will get the same thing, NPR, isn't it? But here how it comes? That is, see, it is the example. Okay, so we have four different objects taken two at a time. So the combinations A, B, B, C, C, D, okay, etc. Now here we can write each selection, we can arrange each selection R times. See, A, B, we can arrange two times, right? A, B and B, A. Okay, so if there are, if taken R at a time, then we can arrange R times, R factorial times. Okay. So NCR is equal to NPR into R factorial. So keep in your mind formula, NCR is equal to n factorial divided by n minus R factorial into R factorial. Don't be confused. NPR is n factorial, NPR n factorial divided by n minus r factorial. Okay, so NPR is equal to n factorial by n minus r factorial. NCR is equal to n factorial divided by n minus r factorial into r factorial. So what is the relationship between NCR and NPR for n different objects? NCR is equal to NPR into r factorial. Now let us go through this theorem. Prove that NCR plus NCR minus 1 is equal to n plus 1 CR. Okay. So what is NCR? First let us go through LHS. NCR plus NCR minus 1, that is equal to, okay, we have to prove RHS. Okay. So here NCR is nothing but n factorial divided by n minus r factorial into r factorial, isn't it? Plus, what is NCR minus 1? In place of r minus 1. Okay. You should be careful. N factorial divided by here n minus r minus 1. Okay. N minus r minus 1 factorial into r factorial. In place of r minus 1. So r minus 1 factorial. Okay. That is equal to here n factorial divided by, write as it is, n minus r factorial into r factorial plus n factorial divided by, here multiply this minus to each terms, n minus r plus 1 factorial into r minus 1 factorial. Okay. Now next, that is equal to here n factorial divided by n minus r factorial. See, we can write r factorial as r into r minus 1 factorial, isn't it? How? See, we know that what is n factorial? N factorial is nothing but n into n minus 1 into n minus 2 into n minus 3 etc. 3 into 2 into 1. Okay. See, take this term separate. Okay. So here, till here, we will write it in factorial. So n into, so till here, what is it? It is nothing but n minus 1 factorial, right? 1 into 2 into 3 into etc. n minus 3, n minus 2, n minus 1. That is n minus 1 factorial, right? So n factorial can be written as n into n minus 1 factorial. Therefore, we can write r factorial as r into r minus 1 factorial. Okay. Plus, here, see, n factorial divided by, now here n minus r plus 1. Okay. So, what is the previous term? See, n minus r plus 1 factorial is n minus r plus 1. Okay. Into n minus r plus 1, see how we will write factorial, n into n minus 1, next n minus 1 minus 1, that is n minus 2, next n minus 2 minus 1, that is n minus 3, okay, in that way. So here n minus r plus 1, so next term is n minus r plus 1 minus 1, right, n minus r plus 1 minus 1, so what is next, n minus r plus 1 minus 1 minus 1, okay, etc. 3, 2, 1, okay, 3 into 2 into 1. Now, here n minus r plus 1, it is nothing but n minus r, next n minus r, it is minus plus 1 minus 1 cancelled, okay, so it will become n minus r, here also plus 1 minus 1 become, so it will be n minus r minus 1, etc. into 3 into 2 into 1. Okay, now here, see, we will write till these terms, okay, till n minus r in factorial. That is 1 into 2 into 3 into etc. n minus r minus 1 into n minus r. That is nothing but n minus r factorial. Okay, so n minus r plus 1 factorial can be written as n minus r plus 1 into n minus r factorial. Okay, because it is the previous term of n minus r plus 1. Okay, see, n factorial, first is n, okay, next n minus 1, subtracting 1, right? Next n minus 2, again subtracting 1. Okay, so here n minus r plus 1, next n minus r. Okay, previous step. Okay, n minus r, that is by subtracting 1. Okay, so n minus r factorial. So n minus r plus 1 factorial can be written as n minus r plus 1 into n minus r factorial. Okay, so here we can write it as n minus r plus 1 into n minus r factorial into r minus 1 factorial. See, why we have written this one? See, so that we can write, we can take outside, okay, common terms. So here what is common? N factorial in numerator is common, right? So we can take it out. Divided by, in denominator, n minus r factorial, r minus 1 factorial are common, right? So take them out. N minus r factorial into r minus 1 factorial. Next, override. So we have taken n factorial divided by n minus r factorial into r minus 1 factorial out. Okay, so remaining here 1 by r plus 1 by here remaining n minus r plus 1. Okay, then take LCM here, write this as it is, n minus r factorial, r minus 1 factorial into n minus r plus 1 divided by r into n minus r plus 1. Okay, that is equal to, so here see, sorry, n minus r plus 1 plus r, okay, taking LCM, right? So cross multiplication, so it will be r. Next, here minus r plus r cancelled. I will write it here, okay? So it will be n factorial divided by n minus r factorial into r minus 1 factorial. Here remaining n plus 1, okay, divided by here r into n minus r plus 1. Okay, then next multiply. N factorial into n plus 1. What is it? N factorial into n plus 1. That is nothing but n plus 1 factorial. Okay, n plus 1 factorial is nothing but n plus 1 into n minus 1, right? If n plus 1, the previous term is n plus 1 minus 1, that is nothing but n. Okay, so n plus 1 factorial is n plus 1 into n minus 1 into n minus 2 into n minus 3, etc. 3 into 2 into 1. Okay, so here n factorial into n plus 1 is nothing but n plus 1 factorial. Okay, divided by here r into r minus 1 factorial. Let us take it together. Okay, so r into r minus 1 factorial is nothing but r factorial, isn't it? R into r minus 1 factorial. Okay, so r minus 1 factorial is nothing but 1 into 2 into 3 into etc. till r minus 1 into r, that is nothing but r factorial. Okay, so r factorial. Next, n minus r factorial into one more term, that is n minus r plus 1. Okay, added 1. So n minus r factorial into n minus r plus 1, that is nothing but n minus r plus 1 factorial. Okay, so here override. Now see, we have got a combination formula. Okay, n plus 1 factorial divided by r factorial into n minus r plus 1. See, we can rewrite n plus 1 factorial. We have to prove this one, right? So r factorial into n plus 1 minus r factorial. So what is NCR? NCR is n factorial divided by, NCR is, see here I have written n factorial divided by n minus r factorial into r factorial, right? So here n plus 1 factorial. In place of n plus 1. So here n plus 1 c. Okay. Here r factorial. So r factorial, right? So here n plus 1 factorial divided by r factorial into, in place of n plus 1. Okay. So n plus 1 minus r factorial. Okay. Therefore it is nothing but n plus 1 cr. Hence it is proved. First question, if NC8 is equal to NC2, find NC2. See, to find NC2, here we have to apply one of the properties of combinations. That is, NCr is equal to NCn minus r. Okay. It is one of the properties of combinations. NCr is equal to NCn minus r. So here we can write NC8 is equal to NC2 implies NC8 is equal to, we will write this one, NCn minus 2. Okay, and one more property, say it is very easiest one. NCx is equal to, if NCx is equal to NCy, that implies x is equal to y. Okay, if NCx is equal to NCy, then x is equal to y. So here we can write n8 is equal to n minus 2, that implies n is equal to 10. Okay, now find the NC2. That is, NC2 is equal to 10C2, n is 10, that is equal to, so what is NCr? N factorial, that is 10 factorial divided by r factorial, so r is 2 here, so 2 factorial into n minus 2, that is 10 minus 2, 8 factorial. Right? Now, see, 10 can be written as 10 factorial into 10 factorial can be written as 10 into 9 into 8 factorial, so that we can cancel 8 factorial, right? Divided by 2 factorial into 8 factorial. 8 factorial cancelled. 2 factorial is nothing but 2, that is 1 into 2. Okay, 2 5s are, so answer is 45. Okay, so NC2 is 45. So remember these properties. NCr is equal to NCn minus r, and it is very simplest one, right? NCx is equal to NCy. If NCx is equal to NCy, then x is equal to y. Next question, if NC9 is equal to NC8, find NC17. So here, first let us take this one. NC9 is equal to NC8. So apply the formula NCr. So NCr is nothing but n factorial divided by r factorial into n minus r factorial. So n factorial divided by n minus 9 factorial into r factorial, that is 9 factorial. That is equal to NC8, that is n factorial divided by n minus 8 factorial into 8 factorial. Okay. See here, in both terms, okay, in both sides, n factorial is n factorial, it will be cancelled. Okay. So n factorial is cancelled. Okay. Next. See, how can we write n minus 9 factorial? N minus 9 factorial. Okay, write as it is. 9 factorial is nothing but 9 into 8 factorial. Okay, that is equal to. Here we can write 9 minus 8 factorial. Sorry, n minus 8 factorial can be written as n minus 9 factorial into n minus 8. Isn't it? See how? What is n minus 8 factorial? N minus 8 factorial is nothing but n minus 8 into, what is the previous term? N minus 8 minus 1, that is n minus 8 minus 1, that is n minus 9. Next, n minus 9 minus 1, that is n minus 10, etc. Right? So, till here we will write it in factorial, that is n minus 8 into n minus 9 factorial. So, 9 minus 8 factorial can be written as n minus 8 into n minus 9 factorial. Don't be confused, okay? I will write it in order. N minus 8 into n minus 9 factorial into 8 factorial. Okay, see, why we have written this one? To cancel, right? N minus 9 factorial, n minus 9 factorial, cancel. 8 factorial, 8 factorial. See, these terms are in both sides, therefore it is cancelled. Remaining 1 by 9 is equal to 1 by n minus 8, isn't it? So take cross multiplication. By cross multiplication we will get n minus 8 is equal to 9. That implies n is equal to 9 plus 8, that is 17. So we have to find NC7. NC17. So n is nothing but 17. So we have to find 17C17. What is it? 17C17. Let us apply the formula. What we will get, let's see. 17 factorial divided by, okay, n factorial, that is 17 factorial, divided by n minus r, that is 17 minus 17. 17 minus 17 factorial into r factorial, that is also 17 factorial. Okay, so 17 factorial divided by, it is 0 factorial, that is nothing but 1, and divided by 17 factorial, that is 1. So remember, NCN is 1. Okay, NCN. So 17C17 is 1. So in generally, NCN, this is also one of the properties of combinations. NCN is equal to 1. Okay, in the same way, NC0 is also 1. How? See, here suppose it is 0. 17 factorial divided by 17 minus 0 factorial into 0 factorial. So it will be 17 by 17. So you will get 1. See, I will write NC0. Apply the formula. N factorial divided by n minus r, right? So that is n minus 0 factorial, okay, into r factorial, that is 0 factorial, okay. Now here n factorial divided by n minus 0 factorial is nothing but n factorial, okay, n factorial itself. 0 factorial is nothing but 1, so it is also n factorial divided by n factorial is 1. So remember, NCN equal to 1, NC0 is equal to 1, okay. So previous properties, that is NCR is equal to NCN minus R, okay. And if NC, one more property we have learned, if NCX is equal to NCY, then X is equal to 1, okay. So remember, NCN is equal to 1, NC0 is equal to 1. Okay, we have found here NC17, that is, we have got n is equal to 17. So NC17 is nothing but 17, C17, that is equal to 1. Let us go through next question. Determine n if 2nC3 is to nC2 is equal to 12 is to 1. See, here we have to find the value of n. Okay, just apply formula of combinations and simplify. So, okay, let us take this one. 2nC3 is to nC2 is equal to 12 is to 1. Apply the formula. Okay, so combinations, that is NCR is nothing but, see, m is to n. How to write? M is to n is nothing but m divided by n, right? So here we can write 2n C3 divided by n C2, that is equal to 12 divided by 1, isn't it? Now apply formula. So 2n C3, NCR is n factorial divided by n minus r factorial into r factorial, right? So here in place of n, 2n, so 2n factorial divided by 2n minus r, that is 2n minus 3, okay, 2n minus 3 factorial into 3 factorial, okay, divided by n factorial into, sorry, n factorial divided by n minus r, that is n minus 2 factorial, because r is 2 here, into 2 factorial, into r factorial, right? Okay, that is equal to 12. 12 divided by 1, 12 itself. So that implies, so here let us write with multiplication taking reciprocal, okay. So it is better to write multiplication. 2n factorial divided by 2n minus 3 factorial into 3 factorial into, take its reciprocal, okay. So n minus 2 factorial into 2 factorial divided by n factorial, that is equal to 12. Okay, then after that, see, we can write 2n factorial as 2n, okay, into, so what is the previous term? 2n minus 1, right? So 2n minus 1, next 2n minus 1 minus 1, that is 2n minus 2, next 2n minus 3 factorial, okay, that is divided by, isn't it? 2n factorial is, see, till 2n minus 3. 2n minus 3 factorial is 2n minus 3, 2n minus 4, 2n minus 5, etc. 3 into 2 into 1, right? So till that we will write it in factorial. So here these are remaining terms, right? 2n is nothing but, 2n factorial is nothing but 2n factorial, 2n into 2n minus 1, next to 2n minus 1 minus 1, that is 2n minus 2, next to 2n minus 2 minus 1, that is 2n minus 3. So next to 2n minus 1 minus 3 minus 1, that is 2n minus 4. So here till here we will write it in factorial, okay. So next in denominator 2n minus 3 factorial into 3 factorial into here n minus 2 factorial into 2 factorial divided by n factorial can be written as n into n minus 1 into n minus 2 factorial, isn't it? See, I have already shown it before. N factorial is n into n minus 1 into n minus 2, next to n minus 3, etc. 3 into 2 into 1. So till here write it in factorial. So n into n minus 1 into n minus 2 factorial, okay. So here, then here 2n minus 3 factorial cancelled, that is equal to 12, okay. 2n minus 3 factorial cancelled, then here n minus 2 factorial cancelled, then here n cancelled, okay. Then see 3 factorial. 3 factorial is nothing but 2 factorial into 3, isn't it? So we can write 3 factorial as 2 factorial into 3, right? So that 2 factorial will cancel, okay. So next remaining, okay, see here 2n minus 2, here we can take 2 outside, okay. So 2 into 2, okay, this 2 and taking 2 outside, so we will get this term, okay, n minus 1 and into 2n minus 1, okay, divided by 3 here into 1 by n minus 1. Remaining terms are cancelled, right? So here remaining 1 by n minus 1, that is equal to 12. Now here see this n minus 1 cancelled, then remaining, okay, 4, okay, 4 3s are 12, okay, that's also cancelled. So remaining here 2n minus 1 divided by 3, here 4 3s are, okay. So here 3. That implies 2n minus 1 is equal to 3 into 3 9, okay. That implies 2n is equal to 9 plus 1 10. This implies n is equal to 5. So we have got n is equal to 5. Just apply the formula and simplification. So you should be careful during simplification. When you do the simplification, you should